Hi, I am Pradosh Kumar, Assistant Professor from the Department of Biomedical Engineering, Sri Shanmuga College of Engineering Technology. In this session, I am going to discuss about the architecture of 8051 microcontroller. So, introduction. It was developed by Intel in 1980. 8-bit microcontroller widely used in embedded systems. The main features of 8051 microcontroller. It is it has 128 bytes of RAM, 4 kilobytes of ROM, two timers are used for this 8051. It has 4 I/O ports, input-output ports, serial communication. This is the pin diagram of 8051 microcontroller. It has totally 40 pins. The first 8 pins are used for communication through port 1, and the ninth is the reset pin, followed by RxT, TXT, that is for transmitting and receiving, interrupt 01, timer 01, write read command. This 8 pins, that is from 10 to 17, is used by port 3, and then followed by XTAL2 and XTAL1, that is the crystal frequencies, and then ground, followed by 21 to 28th pin used for port 2 for address lines. Here, that is 8 address lines can be communicated through the port 2. And then we have PSEN, that is a program status enable, followed by ALE, that is address latch enable, and then external access EA, followed by port 0, that is 8 pins of port 0, still 39th pin, and then we have supply pin, that's VCC for pin number 40. So this is the pin diagram of 8051 microcontroller. This is a block diagram of 8051 architecture. This block diagram, we have seen CPU, which is considered to be the heart of this microcontroller, and we are connected interrupt control, where we can give the interrupts, external interrupts through the interrupt control. Oscillator, this was synchronization, frequency synchronization. We have 4 kilobytes of ROM, that is read only memory, 128 bytes of RAM, random access memory, and then we have two timers, timer 0 and 1, which is used for the purpose of timing calculation and also for counting purpose. And then we have serial port through which we can do the serial communication access, which where TXT and RST pins are used. Then we have I/O ports. We have seen in the pin diagram the 4 ports, P0, P1, P2, P3, which are used for address data accessing. And then we have the bus control, for that is a communication controlling by the bus control. So this is a block diagram of 8051 architecture. So the key blocks of the 8051 are CPU, that's the central processing unit. We have program memory, that is a read-only memory, where we can store the program, and data memory for storing of data, that is a random access memory we are using. We have timers and our counters, that is we can use that as either as a timer or counter based on the initialization of that. And then we have a serial port through which we can do the serial communication using the transmitter and receiver pins. And then we have interrupt control. So different interrupts are there, that controlling will be done using the interrupt control. I/O ports, input output ports, through which we can able to communicate with the microcontroller. The different peripherals can be communicated with the microcontroller. And then we have the oscillator and clock circuit, where the frequency, oscillation frequency of microcontroller 8051 is 11.0592 megahertz. So this is about the CPU, central processing unit. It controls all operations. It fetches, decodes and executes the instructions. We can perform arithmetic and logic operations using ALU, address, so that is arithmetic logic unit. We can work with registers like accumulator, register B, PSW, that is program status word, and SP, that is a stack pointer, and data pointer, DPTR. We can work with different registers using the CPU, central processing unit, which is considered the main part of the microcontroller. This is about the memory organization of 8051. We have 128 bytes of RAM, which is addressing from 00 to 7FH, and we have 32 bytes for register banks and bit addressable memory. We have 4 kilobytes of ROM for storing the program. External memory is expandable up to 64 kilobytes. Using the EA pin, we can access the external memory, that is enable external access enable pin. So this is a special function registers used in 8051 for which we can control and monitor internal operation using special function registers. Is located from address 80 to FF, which is used for special function registers. The examples are accumulator, B register, program status word, T mode, that is timer mode, timer control register, interrupt enable, interrupt priority. All those things are coming under the special function registers. Timers and counters. We have two 16-bit timers, that is timer 0 and timer 1. So using that we can give the timing that is from that is 0000 to 4F. It's till 65,536 delay can be provided using this timer. The modes 13-bit, this is a different modes used in timers: 13-bit mode, 16-bit mode, and 8-bit auto reload mode. The most highly used type of mode is a 16-bit mode. It is used for generating delays or counting external events. That is a major purpose of timers and counters. We can generate the delay, and also we can use to count the different events. These are the interrupts of 8051. Major 5 sources of interrupts are external interrupt 0, timer 0, external interrupt 1, timer 1, serial communication. And apart from we can say that reset also can be considered as a major interrupt which has the highest priority. These all things are managed using interrupt enable and interrupt priority registers. Input or output ports, that is we have 4 IO ports: port 0, port 1, port 2, port 3, using which we can able to communicate with the 8051. Each port is 8-bit wide. You can see that 8 pins are used for the each port. Configurable as input or output. We can either configure the port as input port or output port based on the selection. Port 0 and port 2 used for external memory interfacing. The main purpose of port 0 and 2 is for accessing the external memory. This is a serial communication, which is full duplex UART, that is universal asynchronous receiver transmitter. Full duplex means a communication is possible on both sides. Uses serial buffer and serial control register. We are mainly using these two registers for serial communication: SBUF and SCON. Baud rate generation using timer 1. We can able to select the different baud rate generated using the timer. And then oscillator and clock circuit uses crystal oscillator. The typical frequency of crystal oscillator is 11.0592 megahertz. It provides clock signals for synchronization. So the clock signals are provided by for synchronization using the oscillator and clock circuit. The mission cycle is 12 oscillator period is considered to be one mission cycle. So thank you for listening to my session. Thank you.